Now we shall be discussing about the AS1170.1, which is basically dealing with the permanent, imposed, and other actions. So when we're dealing with the AS1170.1, we basically deals with the we can say self weight of the structure, that is the permanent action. And as per the code, basically that is the section 2 is given for the permanent action. And that is, I can say, is just a single page that is denoted for this particular, we can say, permanent action. So this page is basically guiding us that permanent action shall include the self-weight of the following. Number one is the structure, that is structure self-weight, that is whatever beams, columns, slabs that we are giving, whatever material, that shall basically classify as the permanent action. And after that, all other material incorporated in the structure. So there may be walls, roofings, ceilings, and we can say other permanent construction as appropriate. The third one is the permanent equipment, including fixtures and fittings. So whatever equipment, let us say if we are dealing with the industrial structures, so the weight of the equipment that shall be classified in the permanent action itself. After that, fourth one is the partitions. So partition is basically, a process which is basically dealt with different, concepts as per different countries. Now, in majority of the countries, if the partition is like a very thin wall, and that is a movable partition, most of the times it do happens that the owner or the owner of the house do changes the internal partitions also as per their own requirements. Now, those partitions may be heavy like this or we can say brickwork or blockwork. That is not recommended to be shifted without the approval of the structural engineer, but there may be a light partitions also. So those light partitions, most of the times it do happens that it is not finalized. There may be change in the architectural planning or layout also at the later stages. So what code allows is that the self-weight of the placement partition shall be calculated as per the actual layout. So for which provision has to be made for the movable partitions. That shall be designed for the anticipated weight of the partition placed in any prior positions, but not less than a uniformly distributed permanent load of 0.5 kPa over the area being considered. So let us say this is the room which is surrounded by 4 columns on the outer edges, and till date it may be a possibility that a partition shall may be added here also, partition may be added here also, or there may be a room added here also. So to avoid that ambiguity, what we do is that the code allows that we can add 0.5 kN Newton per meter square over the whole area, and after that you're free to construct the movable partition as per your convenience. So this is like a practical picture where we can see that the partition walls are being constructed and the room layout is being finalized. So that is the, we can say, basic philosophy of the permanent actions. The next the theory that we do need to understand is basically of the imposed actions and other actions also that are given in AS1170.1 itself. So if we have started the structural engineering, then this is the first thing that forms the the foundation or the basis to understand how the structure behaves. Now, as a common philosophy, on the left you can see a parking area, a parking building. On the right you can see a supermarket where we do purchase our monthly grocery or monthly fruits and vegetables. So the action or the loading that needs to be considered is basically given in AS1170.2, and that is different for different occupancies or different buildings. As a common understanding, we can say that whatever loading we are applying here for the parking building, that shall not be same for the supermarket, or we can say that that shall not be same when we're talking about these warehouses also, or the restaurant buildings, or we can say office buildings, or we can say residential building also. Also, for different kind of occupancies of the buildings, the imposed actions, or in we can say simple words, live load or the occupancy load, that shall be different for different buildings as per their different occupancies. So that is given in AS1170.2. So just to start with here, let us say if we are talking about the light vehicle traffic area and medium traffic vehicle traffic areas. So that is like a philosophy that is adopted from the ISO itself. So ISO is basically International Standard Organization, and most of the codes have been written taking the philosophy of the ISO itself with local research and the the local materials that are being used in the construction, and the code is aligned with that. So the light vehicle traffic areas is basically parking garages, driveways, and ramp restricted to cars, light vans, etc., not exceeding 2500 kg gross mass. So we are not saying that the heavy, these kind of, this is sorry, a pram, but for let us say this is in a construction excavator or the heavy bulldozers. So for that it is not applicable. Only for light vehicles, for cars, light vans not exceeding 25 kg gross mass, we can apply area load of 2.5 kPa. We can apply area load of 2.5 kPa, or we can say 2.5 kilonewton per meter square. So that is the load given. But for medium vehicle traffic areas, that is vehicle exceeding 2500 kg mass, but not exceeding 10,000 kgs. So driveways, ramps, repair workshop, footpaths with vehicle access and car parking. So for that, we do need to consider the 5 kN per meter square live load. 5 kN per meter square, and for light vehicle traffic area, it is 2.5 kN, 2.5 kilonewton per meter square. Now you must be, thinking about what exactly is this number written, that is 13 and 31. Now this 13 and 31 is basically the concentrated action in kilonewton. Now what basically happens is that the loading action that we are considering, here we are talking about the area load, but it may happen that the local punching failure may also happen. Let us say we are having this kind of structure, we are putting the steel beam, and in between them we are having this concrete slab. So if we are having this, we can say, concrete slab, let us say this is the concrete slab that we are having, and these are the two steel beams. So for this particular concrete slab, what we can say is that if the vehicle wheel is coming, let us say this is the car, and let us say we have these 4 wheels, or we can say 2 wheels in this particular wheel, and if this wheel is putting a load here, this slab should not fail in the punching. So for local design, it has to be ensured that 13 kN load, when applied over we can say area of 0.3 meter by 0.3, sorry, the concentrated load shall be applied over an area of 350 meters square for calculation of punching or crushing. So the slab should not locally get punched or crush when the wheel load is coming. So we can say here that 13 kilonewton, or we can say 13,000 newton, when applied over a 350 mm square. So 13,000 divided by 350, that much, the local area load has to be applied over a small area. So it is also very important when we are dealing with these kind of movable traffic loads. And similarly, when we are dealing with the medium vehicle traffic areas, it is the values given as 31 kN. And that is like the practical value, because if we are dealing with the vehicle of, let us say, 5,000 kg, that shall not be supported over the, we can say, four tires or 4 supports only. That should be supported on like 7 to 8 tires. So locally, with that approach, it is like calculated as 31 kilonewton. What I'm saying here is that, let us say this is a very big vehicle, and for this very big vehicle, it is not like we are having only 2 wheels. We may have 3 wheels, or we may along this we may have 6 wheels also, we may have 8 wheels also, we may have 10 wheels also. But a local, we can say, actual load, that has to be also be checked, that's 31 kN. So that is the basic philosophy of the imposed action for parking buildings, or we can say light vehicle traffic areas or medium vehicle traffic areas. And we have already like studied here that when we are dealing with different kinds of building, the imposed action is usually different. So for this commercial area, it is different. And if we're talking about, let us say, shopping areas here, yeah. So for shopping area, the load that is given is 4 kN per meter square, or a point load of 3.6 kilonewton. So human weight is usually maximum to maximum, we can say, is that 1.2 kN, assuming a human weighs 120 kg. But 3.6 kN is assumed that there may be a local point load also, or because it is a shopping area, there may be stacking of the goods also, and that stacking is usually putting a point load at the bottom. So for all those, assumptions, 4 kN per meter square, and that is like a value that is used all across the world. For shopping area, it is a fixed that 4 kN per meter square is usually used, and 3.6 kN is the point load that has to be checked over a 350 meter mm square area for calculation, punching or crushing. After that, when we're dealing with a warehouse building, so let us say if we are making a Amazon warehouse, and if we let us say making a warehouse where the goods may be stored. So for that, warehousing and storage areas for reading rooms with book storage, let us libraries, 4 kN per meter square is used, and 2.4 kN per meter square for each meter of the storage height. So that is a completely different thing. Minimum 4 kN per meter square has to be used, but if there is 1 meter additional storage proposed, so 4 plus 2.4, that is 6.4 kN per meter square loading shall be used. Similarly, for concentrated action, it is 4.5 and 7. Now, when we're dealing with the very big brand names, or let us say if we are dealing with this particular warehouse itself. So if I'm the owner, as per my experience, usually the punching load that is considered here, it is usually considered as 6 metric ton or 60 kN, 60 to 90 kN, depending on the number of floors. This is usually known as pallet or pallet racking area. So the projects that I have done, the flooring, the one that you can see on the bottom, the flooring is usually designed for the area load also. The area load is usually considered as 15 kN per meter square. And that is like quite less when we're dealing with these kind of heavy warehouses. But at the same time, when the pallet storage is being done, it is usually supported with the anchors. So here you can see that the protection is also done because 2 anchors are usually coming outside. The anchors are usually coming outside and they have this head. So to avoid the for the safety of the construction workers, it is usually covered. So that is why you can see this particular protection covering around and here on the bottom you can see this plate also. So that is the basic philosophy when we're dealing with the warehouses. But our code is saying that for coming back to the code. So for free rolling office compactors for general filling up to 2 meter height, 3 kN per meter square for each of storage height. For file room, it is usually 5 kN per meter square. For stack room, it is 3.3 kN per meter square for each storage height. For paper storage, it is 4 kPa for each meter of storage height. For cold storage, it is 4.5 kPa, but with a minimum of 15 kPa, that is 1.15 kN per meter square. So this is the value that I was recommending you here. And that is a universal, value that is used. That is for minimum to minimum 15 kN per meter square of area load is used for the flooring design. And Australia has a separate standard for design of industrial flooring. I'm sorry I'm going off the topic, but you should also know. Usually, there is a standard called TR 34, and that is a technical report 34, and that is a European standard. ACI has a separate standard. I'm not able to recall the number, but that has also a separate standard for flooring design. Australia also has a separate standard for flooring design, and that is a very excellent document. I'm not able to recall the number, but I shall be teaching in detail about that flooring design also in a separate course. But that standard is a very excellent standard, and that is usually used when we are dealing with the industrial floors in Australia. So after that, for plant room, it is 5 kPa. And for areas around equipment in boiler room, it is 5 kPa again. So summing up, I shall talk in practical words only. Theoretically, there may be a separate things, but usually when we are dealing with the warehouses, the challenge that we usually get is the design of the roofing. Second challenge that we get, design of cold form, the steel structure for the pallet storage or racking area. So that is also usually designed, and there is this European standard also that is used, and in Australia also we also have a separate standard for the cold form structure design. These are not hot roll design, these are cold form structure members that are used, and they are like quite braced at many places so that at a time of earthquake it does not simply fall. So after that, when we're dealing with the flooring design, as I said that the flooring is usually checked for the area load also and for the point load also. And many times it is checked for the forklift load also. So forklift, if you don't know, you can simply Google, but it is just a small vehicle with a, we can say, in which a person can sit, and it has a very hook at the front face for lifting up of for lifting of the boxes or for lifting of the, we can say, storage. So that is the basic philosophy for the imposed action for the warehouse design. After that, the restaurant. So for areas with tables, the minimum uniformly imposed distributed action in kPa is basically 2 kPa for dining room and lounges, cafes and restaurant. Now this values I can say is a little bit lesser as compared to the other country standards. In US, I think it is in the range of 3 to 4 kPa. In India also it is minimum 4 kPa. In Europe also it is in the range of 3 to 4 kPa. But I'm not sure due to XYZ reasons. In Australia it is only 2 kPa. So for classrooms it is 3 kPa. That is like a universal value that is used in all the countries. After that, for areas with tables is covered for C2 categories, area with fixed seat. That is if you're talking about the classrooms, lecture theaters and similar. For that 3 kPa value is used. And for places of worship, let us say if we want to make a church, so for that we have to consider minimum 4 kPa as the area load. After a C3, so C3 is basically areas without obstacles for moving people. So let us say if we're talking about the corridors, hallways, aisles, stairs, landings, not subjected to wheeled vehicles. So for that it is 4 kPa. For subjected to wheeled vehicle it is 5 kPa. Footpath, terraces and plazas at ground floor it is 5 kPa, and museum floors and art galleries it is subjected to minimum 4 kPa. And balconies, same as areas providing access but not less than 4 kPa. And this language is also typical for all the countries. So similarly we can check the considered action also. So it is like ranging from 2.7 to 4.5 and 31 when we're dealing with the wheeled vehicles here. After that, areas with possible physical activities. Now this is the concept that we were discussing in the earlier lecture. So here we can see that basically dance halls and studios and gymnasia, it is 5 kPa subjected to point load of 3.6, and for drill halls and drill room it is 5 kPa subjected to considered action of 9 kilonewton. Now subjected to C note to clause 3.1b. So this, if we refer to the C note to clause 3.1b, the code is also saying that we have to consider the effect of the vertical impact arising from the usual movement of the people and shifting of the furniture, or we can say the launch does not cover the dynamic effect due to highly active crowds. Because if we are dealing with the dance halls and we can say studios and gymnasia, we are dealing with the highly active crowds. Highly active crowds. So for that, this code is not giving us any guidelines. So for that, what I personally do is that I personally prefer to the AISC design guides, where I can do the vibration analysis, or in ETABS also we have this feature where we can do the vibration analysis and check that whatever frequency is coming, that is in the comfortable range or not. So after that, areas susceptible to overcrowding, that is assembly areas without fixed seatings. It may be concert halls, bars, public lounges, places of worship, shopping malls and grandstands. See, grandstand, we have a separate page also, that also we shall discuss. But here also it is 5 kPa subjected to 3.6 kN of the concentrated action. The maximum value here we can see that here is that in areas section C where people may congregate, that is basically 5 kPa. So after that, the office buildings. So that is also quite common when we are doing the structural consultancies in Australia. So for that, basically the office and work areas not covered elsewhere. For operation theaters, X-ray rooms and utility rooms. These are, I can say, importance level 4 structures. The uniformly distributed action is 3 kPa. For workrooms without storage, it is 3 kPa again. For office of general use, it is 3 kPa. For communal kitchens, 3 kPa again. Institutional kitchen, or we can say commercial, it is 5 kPa. Communal may be like in the places of worship, and for commercial, it may be like when we're dealing with the restaurants, or when we're dealing with the, we can say, bars. After that, for laundries, it is 3 kPa again. For laboratories, it is 3 kPa again, and for factories, it is 5 kPa. Now, this for factories, what I need to add here is that 5 kPa is the minimum, and that is why it is given as general industrial. And that is not valid when we are dealing with the practical industrial structures. See, for practical industrial structures, this value is in the range of, we can say 7.5 to 10 kPa. For general small industrials, we can take it as 5 kPa, but for practical industrial, if you're dealing with the petrochemical industry, if you're dealing with very heavy, we can say, plants, for that we do need to take 7.5 10 kPa, and usually it is the requirement of the customer itself, that what exactly should be the minimum load for which they need to design the structure floors. After that, balcony and floor, that is basically same as areas providing exercise, but not less than 4 kPa. So if we are having we are making the workshop balcony, so for workshop balcony, the load has to be taken as 5 kPa, not 4 kPa. After that, when we're dealing with the fly galleries in theaters, it is 4.5 kN per meter run uniformly distributed over the width. And for grids, it is 2.8 kPa. After that, the self-contained dwellings, it means simple words. The code has to use a very sophisticated language, but I shall use a simple language when we're dealing with the design of the houses. So for houses, it is basically the load that has to be considered as 1.5 kPa. For balconies, for less than 1 meter above ground level, it is 1.5. For upper balconies, it is 2 kPa. For stairs also it is 2 kPa, and for non-habitable roof spaces and self-contained dwelling, it is 0.5 kPa. Now in other countries, this value of 1.5 is usually 2 kPa. Like in US also, or we can say in other countries, Europe or India, this minimum value used is in the range of 2 to 2.5, but in Australia it is restricted to 1.5 kPa only. Similarly, for stairs, this loading is usually in the range of 3 to 4 kPa as per the other country codes, but for Australia it is restricted to 2 kPa. And similarly, for other areas, for general areas, bedroom, hospitals, it is 2 kPa. For communication also it is 3 kPa, and for balconies it is 4 kPa, subjected to considered actions also 1.8 to 2.7 distributed over area of 350 mm square. So that was like the basic introduction to the permanent action and imposed action as per AS 1170.1. So with that, we shall revise our lecture here. We have already studied about the permanent action, that for the partition walls we can take 0.5 kPa as the area load. And the important thing here that we have missed, the live loads given in the standards are characteristic loads. So what exactly is meant by the characteristic load? See, characteristic load is a definition, or we can say a concept that is followed in all the countries. So characteristic load is the value that represents the peak load over the 50-year life with a 5% probability of being exceeded. So we are not saying that, let us say we are taking the 5 kPa as the area load. So there is still a 5% probability that this 5 kPa may go up to as high, let us say 6 kPa also, 7 kPa also, depending on the loading. So this is not the foolproof loading which cannot get exceeded, but there is a possibility of getting exceeded by 5% only. These are the minimum values, and designers should determine if higher values are appropriate. So here in this example, if you're talking about the supermarket floors, it may be treated as a combination of storage areas and areas in which people may congratulate instead of the retail areas. What I'm trying to convey here is that in here we were discussing about the increase in height for the storage. So what just a minute, what I'm trying to convey here is that supermarkets usually have storage also, and in addition to that they have a live load action also. So as per the code, what we can do here is that, let us say this is the retail area, so we can just go to the shopping area, and as per that we'd have to consider the 4 kPa as the minimum load. But on the top of that, we may go for this clause also, where it is written the general storage other than the specified. So it is 2.4 kPa for each meter of the storage height. So let us assuming this LED height is approximately 1.6 meters, so the storage height is approximately 2.5 meter to 3 meter. So 4 kPa is the live load, and in addition to that, the live load that is usually applied in this strip itself. It is not applied over the complete area. So what we can do is that we can bifurcate this area, and in this area, we can apply the 4 kPa load. And on this area where we know that pallet storage racking is done, in this area what we can do here is that we can apply this particular clause here, that is 4 plus 2.4 for each meter of the storage height. So that is how we can ensure that this the design for the supermarket flooring is done correctly. And here also is a practical example. Here you can see that it is not the storage is done only in this area. Here also the storage is done, but at the same time the live load action is 0 here. So you do need to create a balance. So that is why maybe the full height storage is not done here. So the storage height is not like from this area to this area. It is only in this particular area. So this is how the manual, or the maintenance manual has to be given to the end customer, that it is not that you can do the storage anywhere. You have to do storage in the area allotted only, and you cannot store more than this particular height of the storage. So that is how we can calculate the loading for the supermarket also. So these are some common notes that concentrated the SHEP apply for area of 0.025 meter square. So wherever it is given, let us say if we're talking about 13 by 7. So for domestic garages, it is maybe reduced to 9K and applied over an area of 0.3 meter by 0.3 meter. Usually for domestic garages with timber floors, it may be a case where basement may be below that. So that is why it is given, but in majority of the cases it is not like practically applied. So these are some common notes. What we can do here is that, let us say a number is given in the brackets. So this stairs second bracket is given. So second bracket note has to be considered from here. So where a tread or landing is structurally independent of the joining element, it shall be capable of withstanding a lying out of 2.2 kN per meter of span of thread or landing. So we have studied about the warehouse loading also. We have studied about the area where there may be where people may congratulate, and after that for office areas also, for self-contained dwelling, that is the independent houses also. So that sums up the introduction to the permanent and imposed action.